Greg Orloff with IIoT World, and we are back at Hannover Messe this week, and I'm with Parm Sandhu. Parm is the Vice President at NTT Data, and he is in charge of the 5G group, so welcome, Parm.
Thank you, Greg. Thanks for having me here.
So it's been an exciting show so far. Are you finding the events?
Yeah, it's been great, and a lot of new things coming up, and around smart manufacturing, AI. So it's been a great show so far for us as well. Met a lot of nice customers in different countries.
Good. I'm glad to hear that. So I know NTT is focused on some activities at the edge, and you're very keen at data manipulation and integration and some quality control aspects. Why don't you tell us a little bit why you're here at Hannover Messe and what you're exhibiting?
No, actually we're really showcasing our Edge as a Service offering. Okay. What it is a grouping of solutions that we've kind of brought through as part of our new ventures and innovation team from around NTT. Our cloud edge computing that's really designed to allow organizations to build the future use cases that they need to modernize their factories, drive operational excellence, improve worker productivity, worker safety, and really address some of the challenges and cost efficiencies that they need to drive with higher input costs that they're seeing.
Okay, so give us an example.
Yeah, great example. Like right here, we have a couple things where we're leveraging computer vision and AI, and using a very unique way that we're using edge computing. In this case, like an NVIDIA local edge processor that can take lots of images, lots of processing, but there's a lot of data, but not all that data is useful, and that computing local AI can run that model, analyze the image, the quality of the circuit board or a car or inspection, or even a machine from a predictive maintenance, and use that locally to basically determine whether there's something wrong that needs another look at it, right? Or identify a fault or a defect or potentially a replacement. So this is really unique that what we're doing with some of the technology we're bringing in around sensors and aggregation, that improving the capability of the current AI models and really going from like 99% detection of fault detection to 99.99. And by doing that, it's a huge improvement in the performance that we're seeing. Just things like spectrometrology we're showcasing here, and by leveraging this, we can really drive that operational excellence our clients are looking for.
Any particular industry sectors that you're focused on? Or?
Yeah, both. Like I think we're seeing great demand in discrete manufacturing, automotive, the integrated side of it, process and chemical, where there's lots of imaging and computer vision for inspection, worker safety, inspecting of their equipment, remote access and remote support, and really also in supply chain. Supply chain is a great area where we can help the 3PL type companies to really reduce errors in their processes and process re-engineering. So we're covering all of those areas now, and then we're starting to see growth in other areas like healthcare for a lot of these services as well.
Peel the onion for us a little bit. Give me an example of something where you've seen that in the supply chain. Maybe you don't have to name names. Just
I'll give you an example where one area we're looking at right now is smart tools. Okay. So if we have an automotive sector where nowadays, especially with how complex the cars are, you've got, for example, in smart tool case, the torque wrench is like a $16,000 US dollar torque wrench.
Expensive tool.
It's
right?
a very expensive tool, but the biggest problem is, there's a lot of different bolts, and it's not quite sure which is it on the right bolt with the right setting, especially in aluminum cars, aluminum chassis. That if the wrong torque is applied to the wrong, bolt, and these bolts are millimeters apart, you have to be able to detect the location of that torque wrench within millimeters, but it has to be done in real time. So it has to be done in milliseconds, in less than 20 milliseconds, because the human interaction and response times are so much faster. And if we detect it, it's put on the wrong bolt, we have to shut that off. So that really has to be done in real time, local processing, and then we use that response with 5G to really interact with the human. Another area that we're looking at is vehicle inspection at the end.
Okay.
So how do we detect where in a car, which is designed not to detect imperfections, the paint of the car is reflective. It's very difficult for the human eye to see it.
On purpose, right?
On purpose,
it's
designed that way.
Okay.
I mean, there's engineers whose whole goal is to actually how to make the paint so that it hides the imperfections and scratches, etc. Okay. So with computer vision, we can create a full digital twin and really make it assistive to the end inspector, the quality inspector at the end of the line, who can actually then be identified through AR where the defects are. So those are types of use cases that we're seeing. And what that's really doing is it's making those, making the worker more productive, driving efficiency, greater quality, but also creating that auditable image analytics data that we can say, look, this product or this product was shipped with this quality. Now you have a digital fingerprint of that, or in the supply chain, in the picking of warehousing, where we can identify any wrong products that are picked. And we can validate, and we have an image of the order that we can now say, the right products were shipped, and really reduce any kind of error rate, which has a huge impact in supply chain, right?
So talk to me a little bit. I know one of the main themes at Hannover Messe this year is the artificial intelligence and
yes.
leveraging AI. So how are you incorporating that into this whole model?
Yeah, so we're running AI at the edge. And what we see is that, especially in manufacturing processes where there's a lot of data. In this example that we have here, this inspecting a motherboard that's been manufactured, in 1 second we're generating 6 gigabytes of data.
A second, 6 gigabytes a second.
Yeah, in less than a second. So we need to process, and a lot of that times, like 99% of these boards are going to be fine, so it doesn't make sense to send that into the cloud to analyze it. By being able to look at that processing locally at the edge on a small edge compute device or an edge at a factory, we're not having to send all that data. And in fact, these boards are produced in seconds. So we can't wait for the data to be sent up, analyzed, and sent down.
We
need to reject it. You'll lose too much parts, part efficiency or machine efficiency as you're going through those latency and detecting. So really trying to do all of that at the edge, and that's what we're seeing. By also integrating additional technologies like computer vision, we're able to improve the quality of that AI, the detection algorithms. Because AI is all about quality of data, quality of image, and so that in the analysis, so anything we can bring together, we improve that from 99% to higher quality detection. It really improves that, right?
So Parm, what are we looking at now? We've got another demonstration here from
NTT.
NTT.
So what we wanted to show here is how NTT is bringing the entire Edge as a Service offering together with our private 5G. This is we call this our private 5G network in a box. Basically it would be a full 5G network, but these radios would be deployed throughout the factory. What we created was something where companies can leverage and build their prototype applications for DevOps environment in their R&D lab, in their factory, and really makes 5G really simple plug and play. Easy to integrate into their LAN. What this is really is a full 5G network. All they need to do is plug an Ethernet cable and a power supply.
So it's plug and play.
Plug and play, truly. And then we just give them the SIMs and they can connect the devices that they need and build out their use cases and applications. And what it makes is it makes it real. They can actually trial their applications and build them. So here what we're showcasing is we're bringing NTT Private 5G and Edge computing together. And we have what we call our small form factor Edge compute device, it's Spectra Edge. So what happens in a lot of factories is they have a lot of sensors and data. And here what we have is we're just using an industry standard, industrial sensor that has humidity, temperature, and really, these could be hundreds of these sensors. What we've done is really made these solutions manageable, where you can deploy these and it can handle any kind of sensors, different Bluetooth sensors, Wi-Fi sensors that are out there, and basically put this throughout the factory and connect those via 5G into a central computing processing engine.
Got it. And does that tie up the cloud to you folks then as well?
Yeah, exactly. So here in this scenario, we're working with our partner Litmus, Litmus Technologies, and we're basically bringing the data using their Litmus Edge, which is running on our platform here. And it can take the data from all kinds of over 400 or 500 sensors that they've basically done all the drivers and protocol conversions for, and be able to ingest it into a cloud. And what we're doing here, we're just doing a showcase with Litmus, where we're showcasing the humidity and temperature from that sensor. So really making it easy for a customer, the full Edge as a Service, by bringing it all together so that they can now leverage that data, warehouse, in a factory. You can look at and see how that motor is performing, maybe, or in a process. Like if you're storing things like in process manufacturing, it's very important that products are stored at a certain temperature and humidity, right? So we can apply these use cases very horizontally across.
Great. Oh, great example. Thank you for sharing, Parm.
Thank you, thanks again.